Okay, so here's a practice problem adding vectors. We're adding vectors. We have a vector of A that's 6 at 20 degrees, B is 10 at 130 degrees, and C is 8 at 40 degrees. And we're told that we want to do vector A plus vector B minus vector C. So we're going to use that pattern to put these together. So what we need to do is we'll sketch out A just at 20 degrees and draw that there. Then B is 10, so it's a little bit longer at 130 degrees. And then C would kind of go off at 40 degrees in that direction. But we want to do minus C, so we want to go the opposite direction. So we're going to draw C down that way. And then our resultant starts where we started, ends where we ended, and we get our resultant like that. To get the resultant length, what we need to do is find out how much of that is in the X and how much of that is in the Y. And that'll allow us to do the Pythagorean theorem to find the resultant length. So the resultant in the X, what we're going to do is look at the shadows of these. So A goes off to the right about that much. Then B is going to bring us back. And then C is going to bring us all the way back more when we do A plus B minus C. And then we'll do the same thing for the Y. A takes us up a little bit. B takes us up more. And then when we subtract C, that minus C that is going to bring us back down, and that's going to be the resultant in the Y, is the combination of all that. So we need to get the X and Y components of each of these vectors. So AX is A cosine theta, where A is 6, and then we do the cosine, and the angle is 20, and that's going to give us 5.6. AY is A sine theta, which again is 6 and 20, but now we're doing sine, and that gives us 2. Then we do BX is B cosine theta, and remember B is 10, and we do cosine of 130, and that gives us negative 6.4, which is that going backwards there. BY is B sine theta, which again, same numbers, we just switched to sine, so 10 sine 30, and that gives us 7.6. Then again, the same thing for C. CX is C cosine theta. C is 8. And then we do the cosine of the angle, which is 40 degrees. And that gives us a value of 6.1. And CY, C sine theta, same numbers, 8 sine 40, gives us 5.1. Then again, remember, we want to work with this right triangle. We need to get RX and RY to use the Pythagorean theorem. So RX is AX plus BX minus CX. We follow the same code that we were given at the beginning, which is A plus B minus C. So we bring our AX value over and our BX value over, which was negative 6.4. And then our CX, we do minus the 6.1. And we get an X resultant of negative 6.9. And we do the same thing in the Y, AY plus BY minus CY. So our AY is 2, plus our BY of 7.6, minus our CY of 5.1. And that gives us a resultant in the Y of 4.5. And now we can sketch this out. Minus 6.9 means 6.9 to the left. Y of 4.5 means 4.5 up. Our resultant is that hypotenuse, so we do Pythagorean theorem. And we can find out that the resultant is 8.2. But we also need to know what direction. We're looking at that angle there. And the tangent of theta is the Y, the opposite value, over the X, the adjacent. But we don't want that. We want the theta, so we need to do the inverse tangent. The tangent gives us theta. So we have to do inverse tangent of the other side. So what we really have is inverse tangent of our RY value, which is 4.5, over our RX value, which is 6.9. And that gives us an angle of 33 degrees. But we need to make sure we get that in quadrant 2. So remember, we need to go up like that. So we want to do 33 degrees above the negative X axis.